Hi there, we're going to look today at exercise 7e. So we've previously seen the area of a triangle. I remember that in the year 12 book, chapter 11 from memory. And we've also recently seen the area of a sector area of an arc length, sorry. So we're going to use some of these ideas together now to find areas of triangles in circles. That's the plan at least. So let's have a go. So triangles, we need to be able to find that triangle there. You can see it's within a circle. Because it's a circle, that radius is equal to this radius. And we've got a rule, of course, which says the area of any triangle. And that rule is half AB sine C. But in this particular case, the two lengths of the sides are both the same. Both are. And they will always be R. It'll just be the radius. And then the angle in between them, of course, is theta. So I rather than half AB sine C, I get half R squared sine theta. And this rule is an important rule. You don't get told it, you're meant to know it. Okay, so we're going to want to use that. We'll also need this. And effectively, look at this. A squared equals B squared plus C squared minus 2BC cos A. This is a rule that finds the length, in this case AB. It's the length of this chord. And normally you would have two sides and you'd find the opposite angle, the opposite side to the angle. So, but here, of course, we've got, well, we've got the B squared is R squared and the other one is R squared as well. So we end up with AB squared equals 2R squared minus 2R squared cos theta. Just chucking it there. There's an R squared, there's an R squared, we've got two of them. And 2R. But you'll notice the 2R squared comes up. And we can therefore factorise it to give me this. And this is probably worth writing down. You can just use a bit of common sense and just work it out. Or you can learn that formula. Or you might be expected to know this formula or prove this formula. AB squared equals 2R squared in brackets 1 minus cos theta. Remember this rule works for all types of angles. This is rads or degrees, but other rules we're going to see in a bit will only work for radians, so therefore you're probably best sticking to radians when you're doing this. So here's a question then. Find the area of the triangle and the length of its chord. Well, straight away I'm thinking to myself, the area is a half, well it says up here, R squared sine theta. So it's a half times 4 squared times sine. Theta is 2 radians, it says. So I've checked onto my calculator. Just got a little check, make sure my angle is in radians. Good, mine is now, if not sure. Remember it's shift setup, which is next to the menu button, or is the menu button. So it's anyway, it's a half times by 4 squared times by sine of 2. 2 is about 100 odd degrees. Anyway, I've got 7.27. Now this is centimetres squared. It's a relatively easy formula. We also want the length of its chord. So the length of its chord, what I called AB just now, but here it's XY. So I'm going to write XY squared equals. And if we just go back and have a look at that formula, it says 2R squared 1 minus cos theta. So we might as well learn this. It's 2R squared 1 minus cos theta. And in this case it's 2 times 4 squared 1 minus cos of 2. That's of course the xy squared, so we will have to square root at the end. So I just typed it all in and I got 45.31. So when I square root that, xy becomes, let's just do it, square root the answer, 6.73. I definitely remember it was 6 something. I can't remember if it was 6.73. Yes, it was. So good. We're happy with that. Next example. Now this is often asked of us, and it involves using two rules now. So sometimes we want what's called this segment. This part here, which is cut off by the chord xy, it's called a segment. And we find it basically by doing all of this area, which is the sector, and we take away then the triangle. So let's start off with this. I'm going to do the sector. Now the formula for the area of a sector is this one here. No, it's this one here, which is very similar to the outline of the triangle. So for the sector, it's a half r squared theta. This is one that only works in radians. So it's a half times, what's the radius? The radius, it says, is 5, so 5 squared. And the angle is 2/3 of pi. So there you go. I might as well type it into my calculator. So a half times 5 squared times 2/3 of pi. And I get, does it want exact? I think it wants exact 26.18. If it wants it exactly, I got 25/3 pi. So it's, I suppose that's worth bearing in mind as to what exactly they want. Now that's the sector. That's the big thing. That's what I'm colouring in now. But I don't want that. I just want this bit that's been shaded in. So I need to take away the triangle. So the triangle is a half r squared sine theta. This is what we've just been doing. So it's a half times 5 squared times sine theta. And the angle is 2/3 of pi. So very similar. Let's just do it now. So I'm typing it in. In fact, I can cheat a bit because it's already on my screen. So I'm just changing it. Half times 5 squared times sine 2/3 over pi. And I get, well, it's a bit messy, 10.83 as a decimal. And again, I'm not sure what they wanted. I suspect that was it. But if they wanted it, well, exactly, I got 25√3/4. Or according to my calculator anyway. So, okay, so that's two answers. So what do I want? I want that segment. The segment then is one of them, 26.18, minus the other one, 10.83. Which sounds to me like 1615-ish. 26.18 minus 10.83. And notice I've done them to two decimal places, and therefore that allows me to have my final answer to three significant figures. And I get 15.35. Oh, it's slightly concerning. Is it 35? I'm going to write 35. Is it 35 meaning round up, or is this a slight error and really I shouldn't be rounding up? So that was this segment. I want to see that. Yeah, it was right, 15.4. And now we're going to try to do it says the perimeter of the minor segment. Now, first of all, the minor segment is this little bit here. This is a strange way of describing it, minor being small. And this one here is the major segment. Sometimes, if you've done the last exercise, you'll know that that is sometimes asked for, but not very often. So anyway, that's what I'm after. But the perimeter of this segment has also got this section here. So that's what I need to, oh, I went the wrong way. That's what I need to do. So I've got, that is essentially what is my picture. And so it said it's 5. I need this distance around here, and then I also need this chord. So the let's do the chord first of all. We did that just now. It's 2r squared 1 minus cos theta. That's what we come up with as a simplified version of this. So it's 2 times 5 squared 1 minus the cos of 2/3 of pi. So let's just do that. So I'm just typing it in. And I get exactly 75. I'm not sure if that's right. That's the chord. But that's got to then, remember that's, well, I don't know what it's called. Last time it was called XY, so I'm going to call it XY as well. And that's squared, so presumably my chord really is that square rooted. It's 5√3. And again, I might as well leave it like that for a moment and then change it to a decimal at the end. Now, the next thing I want to do is to work out this distance here. Now, this is actually quite easy. The arc is just r theta, and that's 5 times 2/3 of pi. 5 times 2/3 of pi, and that's 10.47. So the total perimeter is the two things added together. So I'm going to get 5√3 plus that 10.47, and I get 19.1 to 1, well, to 3 sig figs. So I'm good. And did I get 50? Yeah, I checked that already. That's right already. So now look, quite a tough question. It says find the angle here. You'll notice I've got two of these intersecting circles. First, find the length PQ. Well, that's just now we've got this formula for PQ. I'm going to write PQ squared. I can use the left-hand side. Now remember it was 2r squared, 1 minus cos theta. That's worth writing down. So it's 2 times 5 squared, 1 minus, so it says 45 degrees. Now I think I'd prefer that as pi by 4. Simply because then I can stick with pi by 4 all the way through this. I don't have to change it if I need to do anything in radians using the other formula. So I'm typing this in, 2 times 5 squared times by, in brackets, 1 minus cos of pi by 4. Okay, so I get 14.64, and therefore PQ, according to me when I square root it, is 3.82. 3. Find the missing angle. Now the missing angle comes about from the fact that this distance is the same no matter which way round you do it. So I can find that PQ, well I have 3.83, but I can also do it on this side. So if I do it on the other side, I know that 14.64, that's the PQ squared thing. But it now equals the same thing on this side, so it equals 2r squared, 1 minus cos theta. Different r, different cos. So it's 2 times 3 squared, 1 minus cos theta. So that, if I move that over, that's 9, that's 18. 14.64 divided by 18 is 1 minus cos theta. So when I do that division, I get 0.8133 equals 1 minus cos theta. They obviously switch places, and that gives me cos theta equals 0.1867. And if I inverse cos 0.1867, I get 1.38 radians. So 1.38 radians. Or if I want it in degrees, I have to times it by 180 and divide by pi. And that gives me 79.2 degrees. So hopefully that is right. I'll carry on because I think from memory there's a part C. Yeah, find the area of the shaded region. Well, to get the shaded region, I've got to do on the left-hand side and the right-hand side that thing I was doing. And so you work out the sector for both sides and you work out the triangle for both sides. So there's a simple formula for doing it. You can combine it. It's a half r squared, and it's a big one, which is the theta minus sine theta. That's the two formulas together. So on the left-hand side, that's half times 5 squared. Theta's pi by 4, so I shall write that there, minus sine pi by 4. And unfortunately, because I'm running out of time, I've typed this in, I've got 0.979. Now I do the other side as well for this side of it, and it's the same formula, so it's a half times 3 squared. Now the angle was 1.38, and accurately it's 1.383 radians, minus the sine of 1.383, and again I've already typed this in, and this gives me 1.803. So I need to add that to that, and when I got done that, the total area, I got 2.782 square centimeters. So hopefully they're right, and yes they are. So you were meant to do exercise 7E now. 7E, from memory, the hardest bits are the ones where you've got those two circles combined. The rest of it should be fairly straightforward. And any problems, let me know.